I'd like to talk about the Fly Zero study we conducted last year. So this was set up by the ATI, ran through last year and up to Q1 this year. This was a government-funded study, and we brought together around 100 people from across the industry. I had the privilege of acting as the chief engineer for the propulsion system study. We were tasked with exploring the different options around future zero carbon technologies and concepts, and coming back with recommendations on what the best solutions could be in the future. This was a holistic study looking at the full sustainability picture across different emissions types, considering the different options for fuel and energy sources. We looked at the market economics, the ground-based infrastructure challenges, and we came up with a series of actual aircraft concepts to embody the technology. Early on, we looked at the different options, the different fuel solutions, to address significant weight class, size, and range of aircraft. And we concluded that the best strategic choice for green flight, zero carbon flight in the future, would be liquid hydrogen, because of its lightweight nature. Dominates in aviation, as you have to lift clearly everything off the ground. Mass is very important. We explored different powertrain technologies here. We looked at fuel cell options, and we looked at combusting hydrogen into gas turbines, and we came up with 3 concept vehicles. These were to address the regional market around the weight class of an ATR 72, the narrowbody market around the weight class of an A320neo, and we also pushed the boundary as to what could be done right up into the wide-body mid-size space. And we generated a conceptual design of a wide-body aircraft that could, in the future, allow hydrogen flight to take you anywhere in the world with a single stop and refuel. And I believe this is an important finding that shows hydrogen-fueled flight can address the mass market in the future. And this can really push up the priority in terms of future investment by governments, by industry, by universities, by research organizations in addressing that hydrogen challenge, and push up the priority for the parallel challenge of the ground-based infrastructure in the investment in the production of the fuel and in the investment around airports to allow liquid hydrogen to be stored and to enable safe, rapid refueling of aircraft to maximize the utilization in the future. The study was supported and populated by people from many of the big existing players in aerospace. We had a series of people from Airbus, Rolls-Royce, GKN, Spirit, and many others. We ran a series of working groups where we had a two-way dialogue with a number of airports and a number of airlines to discuss how these aircraft could be used and what the infrastructure challenge is and how we might overcome that in the future around airports. So overall, I believe this was a wide-reaching study in terms of its scope and how we reach the industry, and it paints a positive light for the future of hydrogen, how it can address the mass market. And we published a series of technology roadmaps to drive future tangible action to address some of these challenges for the future. To give a balanced view on this, there are a series of challenges that need to be addressed. So technically, hydrogen has a number of challenges compared to kerosene. It needs to be kept very cold on board. It needs to be well insulated to do so. And because of this, it needs to be moved out of the wing and into the fuselage. We dealt with these challenges and how you would embody these in aircraft concepts on Fly Zero. Also, as a fuel, it has a number of safety challenges which need to be, the debate on how we create fit-for-purpose certification guidelines need to be addressed on these. Some of the things that need to be addressed are that the fuel expands to over 800 times its volume when it's exposed to atmosphere and becomes a gas, and it has significantly lower ignition energy than kerosene as well. There's also a significant parallel challenge, as I said earlier, in the ground-based infrastructure, both in the production of the fuel and scaling that up around the world and making that a green supply chain, and in the airport-based infrastructure. To this last point, I think that the study showed that hydrogen could address the mass market, and so in doing so, you can somewhat break the egg problem of moving first on the development of the technology and the infrastructure, and that both need to be developed and both are worthy of investment as a high priority from government and industry because of that future mass market applicability and the fact that you emit zero CO2 using hydrogen.